If you think excessive antibiotic use is at the root cause of your gut and other health problems, you're probably right. In my experience, it's the trigger about 70% of the time. Welcome to this presentation on antibiotics and their effects on the microbiome, where you'll learn information that you'll find nowhere else. The bottom line, when antibiotics kill off too many pH, oxygen, antibiotic-sensitive butyrate-producing health promoters, the dynamics of the microbiome dramatically change to favor opportunistic pathogens. While the conventional medical community is concerned about antibiotic resistance, understandably so, I'm focused on antibiotic-driven dysbiosis, which affects many millions more people. I know this is a sensitive topic, as we tend to view antibiotics as essential in every emergency, and doctors practice CYA medicine because they don't want to get sued, but studies show some 30% of these prescriptions are unnecessary, and it could be argued more than that. We're always so concerned about things in the short term, but don't consider the long-term repercussions. Fear tends to outweigh logic, but consider this presentation and at least you'll be armed with more information than anyone else you can bump into. If you're new, be sure to subscribe to my YouTube channel and also follow me on Instagram and Facebook as The Microbiome Expert. We begin with this quote from this 2024 paper, which states, quote, "A large body of epidemiological, interventional, and experimental evidence shows that exposure to antibiotics has long-term negative effects on human health." These authors are saying the same things that I'm saying, and by the time we're done, you'll understand the connection better. And if you're familiar with my videos, this next quote from this review will ring some bells. My focus is on the root cause, in this case, chronic inflammation from the gut caused primarily by excessive antibiotic use. I want to bring that dysbiosis back into balance. I don't focus on killing. I focus on nourishing the health promoters who have been sidelined because the gut environment no longer is in their favor. And who are these crucial health promoters? They have names like F. prausnitzii, E. rectale, Roseburia, Ruminococcus, and Eubacterium. If you're familiar with my videos, you know these names well by now. These butyrate-producing bacteria don't exist as probiotics. You have to intelligently feed them the fuels they love so they can overcome the environment controlled by the opportunistic pathogens I'm always talking about, who have names like E. faecalis, F. nucleatum, Klebsiella, Veillonella, and E. coli. From this figure, you can see a clear drop-off in the good guys and a clear increase in the bad with antibiotics. However, you can see both rebound to varying degrees following antibiotics discontinuation. This is common, that the microbiome can generally handle a round of antibiotics once in a while and more or less recover in a month or so. Now, one round of antibiotics in all likelihood is not going to drive disease. The data shows this. But multiple rounds, especially in succession, will alter your microbiome for the worse. Take the time to read the text box to the left, which is very important and highlights a key principle I frequently mention and helps explain why you are reacting to more and more foods and other factors within your environment. To focus on the bad actors, in this study, the results showed that metronidazole increased what they called Enterococcus domination threefold. What's that? They defined it as when at least 30% of the microbiome is occupied by a single taxon. Well, that very rarely happens, and if it happens with a species from Enterococcus, you're in very bad shape. You can see the results in Figure B up to 35 days post-antibiotics. Interestingly, the Enterococcus domination, largely caused by metronidazole, caused a 9-fold increase in risk for vancomycin-resistant Enterococcus bacteremia, a different class of antibiotics. If we take antibiotic use to a bit of an extreme, here we have 16 healthy, brave souls who took ciprofloxacin, vancomycin, and metronidazole for 7 days, the goal being to measure their combined effects. The colors in the heat map, Figure C, indicate logarithmic changes, black a reduction, white an increase. The green arrows point to the health promoters I've established over the years as the former director of medical education for a microbiome firm. You can see massive differences from day 0 to the collection of the fecal samples on day 9. Several key health promoters were reduced over 100-fold, while a classic opportunistic pathogen, Streptococcus, was significantly increased, as was the genus Lactobacillus, your so-called probiotic behaving as a bad actor. You can see here in this study the common antibiotics pattern, this time by colors. Within the blue rectangle, you can see at 9 days post-antibiotics, drastic changes from day 0 in the colors, which represent the abundance of various genera. Most obvious is a huge increase in the color red, which represents the genus Streptococcus, a genus full of bad actors. Also, again, we see a huge increase in Lactobacillus, acting like an opportunistic pathogen once again. Lactobacillus may be good for infant and vaginal health, but my data shows the opposite for adults, especially for those who are dysbiotic. The authors are going to state, quote, "We observed profound changes shortly after the course of antibiotics, with a drop in microbial diversity, overgrowth of the genera Streptococcus and Lactobacillus, and an early loss of anaerobic bacterial taxa with important roles in short-chain fatty acid metabolism." That last part, anaerobic taxa with roles in short-chain fatty acid metabolism, those are the health promoters. There are a number of interesting things I could point out from this study, but let's just say that their overall findings were in accordance with everything else. Post-antibiotics, bad guys up, good guys down, and with time, a partial but not complete recovery. But here I want to show you something different. In Figure 5, we see significant increases in the first 2 time points of what are called virulence factors. These are some of the things that make the bad guys bad. These are increases in the expression of their genes, which are involved in iron uptake, bad bacteria love iron for growth, LPS, the coating of their outer membrane, which the immune system is highly reactive to, and genes involved in adhesion and invasion. These are also classical traits of opportunistic pathogens who want to adhere to and invade the cells that line your gut. You need to understand that opportunistic pathogens, like Enterococcus, E. coli, and others, are a normal part of the gut microbiome. But when given the opportunity to be in charge, they will take it, hence the name opportunistic pathogen. And in this pro-inflammatory environment which they create, they cease to be normal members of the microbiome, and instead they become more pathogenic through modification of gene expression. From this comprehensive meta-analysis, we see the effects of antibiotics on aerobic bacteria. As a rule, but certainly not always is the case, aerobic bacteria have more bad actors, more opportunistic pathogens, while the true health promoters are very oxygen sensitive. So here we see a list of common bad guys, such as Enterococcus, Escherichia, Klebsiella, and Streptococcus, names I frequently mention. The color red indicates an increase in their presence. Within each cell are the references they highlight. As you can see, there is a lot of red. But wait! These are bad guys. Shouldn't they be reduced by the use of antibiotics? Antibiotics kill bacteria, both good and bad. But you're never going to kill off all opportunistic pathogens from their reservoir, the gut microbiome. And following antibiotic therapy, the bad guys tend to come back stronger as the new environment favors them. Why? Because the good guys tend to get killed off more so from antibiotics, which is what we see here. These are the anaerobic bacteria. Again, as a rule, these are health promoters like Coprococcus, Eubacterium, Faecalibacterium, Roseburia, and Ruminococcus, names with which you're becoming familiar if you watch my presentations. We see a lot of green. That means reductions in their abundance. And the bit of red we do see, which means increased abundance, that's for C. diff, as in a C. diff infection. However, a giant point of note, the number one cause for a C. diff infection is excessive antibiotic use. Also note for the rest of this table, the significant increases shown for Candida, as in yeast, across all antibiotics. Like bad bacteria, Candida is also an opportunistic pathogen, waiting to take advantage of an environment which serves it best. When you wipe out the bacteria, to include the good guys, Candida has a free pass to become opportunistic. Returning to the anaerobic bacteria, we see a lot more green reduction here, especially for clindamycin, and here for ciprofloxacin. So let's take a look at some of those good guys who we saw got impacted from our previous table. In this study, healthy subjects were given a 10-day round of ciprofloxacin or clindamycin or placebo, and their fecal microbiomes were evaluated at 6 time points out to 1 year. We can see in this figure at various time points, with each antibiotic, the true health promoters of the gut were significantly reduced, to include Faecalibacterium, Roseburia, Lactobacillus, Enterococcus, and Pneumococcus. The most profound shifts were in the first month. However, in general, the microbiome inhabitants recovered over time, although at 1 year out, the good guys had generally not returned to their initial levels. So let's highlight a few conditions from some papers to give you an idea of how widely known this data is. Data which, in theory, your doctor should know, even though the medical system is slinging antibiotics at people left and right. How do I know this? Because I routinely hear of people who have taken 50, 75, and even 100 or more rounds of antibiotics in their lifetimes, and obviously suffer from gut issues, among many other things. Here these authors state that, quote, antibiotic use is the major risk factor for a C. diff infection. And here we see a significant increase in the risk for Crohn's disease in children with antibiotic exposure. And also in children, we see increased risks in a slew of conditions with antibiotic exposure. And here is a slide from my video entitled Fungi, Yeast, Candida, and the Microbiome. Antibiotics are a huge risk factor for vulvovaginal candidiasis, as highlighted here. And antibiotics don't just affect the gut microbiome. As a part of this collateral damage, the health-promoting bacteria in the vagina, like L. crispatus, tend to get killed off or at least sidelined. Like in the gut, this is where the not-so-health-promoting occupants take over. This is why women who have had many rounds of antibiotics tend to have chronic yeast infections. And here we have a slide from my video on UTIs. This study looked at antibiotic use and the risk of cystitis and UTIs. They found that the risk for a UTI 15 to 28 days post-antibiotics was more than 2.5-fold in one cohort of 326 women, and a whopping almost 6-fold in a cohort of 425 other women. But when they looked within 14 days, the risk was not significant. Now this makes sense, right? Antibiotics kill bacteria, both good and bad. But following discontinuation, the bad actors rebound faster and stronger. You're not going to kill off all the bad actors with antibiotics, or any other natural antimicrobial for that matter, like oregano oil, berberines, and so forth. More on this later. You need to address the whole environment so the good guys are in charge, and so the bad actors are kept in check, and are not given the opportunity to become opportunistic. And here we have a slide from my video on diverticulitis. These researchers found that among 29,168 women without a history of diverticulitis at baseline, with a mean age of 72 years, that prior antibiotic use in mid and late adulthood and recent antibiotic use, regardless of age, were independently associated with subsequent development of acute colonic diverticulitis. They go on to state, what I and many others do as well, that, quote, the use of antibiotics, which may irrevocably configure gut microbial communities into unfavorable ecological states, more prone to digestive diseases associated with perturbations in host microbial interaction. So here we have a list of all the opportunistic pathogens which consistently come up in my meta-analyses and in a broad array of other papers. Some you may recognize. Are there other bad-acting bacteria? Sure, but these are the most consistent across all conditions. And really, Eggerichella, Enterobacter, and Fusobacterium aren't as common as the remaining 7. Note that your so-called probiotic, Lactobacillus, is on this list. And if you look at column 3, you see which of these are consistently increased with PPI, proton pump inhibitor use, as shown in multiple trials. See that video for more. And in the next column, you see which bacteria have been shown in multiple trials to be consistently increased with antibiotics. We saw most of these names earlier. Now we'll look at more data to reinforce the point. If you're familiar with my videos, you know this chart. If not, let me briefly review. This and the coming slides are meta-analyses for all of the conditions which I have analyzed over many years. This chart here is the average microbial fingerprint of autoimmune disease taken from original research in humans analyzing the fecal microbiome of those with various autoimmune diseases versus healthy controls. Along the bottom, the x-axis, we have the keystone taxa, the taxa which have the most consistent data points. Their columns are the number of studies where any significant difference was found between autoimmune subjects versus healthy controls. Green signifies a significantly higher abundance of the taxon in healthy controls, while orange signifies significantly higher in the condition, in this case, autoimmune disease. You can learn more about this in my 2-part series here. For this, in each coming slide, I've marked our previous opportunistic pathogens we just talked about with an orange arrow, when they are a part of the average microbial fingerprint. As you can see here, 8 of the 10 are consistently, significantly elevated in those with autoimmune disease. To highlight the superhero of the microbiome, F. prausnitzii, which is one of many health-promoting taxa, I've marked it with a green arrow. Keep an eye on it. And lastly, I've circled Lactobacillus, your so-called probiotic, whenever it's a part of the microbial signature for a given condition. Note who it groups with, F. prausnitzii in green or the bad guys in orange. You'll be seeing incredible consistency, which is no coincidence for all of these taxa. I hope you're enjoying the video so far. Don't forget to like, subscribe, and recommend to friends and family. Also, if you're feeling extra generous, hit the super thanks below. Here we have the microbial signature for a C. diff infection. We see 5 of our opportunistic pathogens as a part of the microbial fingerprint. 4 of the 5 have been shown to be consistently increased with antibiotic use, which makes sense, as the biggest risk factor for a C. diff infection is excessive antibiotic use. Note F. prausnitzii, all green, always significantly higher in healthy controls when a significant difference was found. And note Lactobacillus, with even more bad data points than E. coli. In this video, you can learn much more about C. diff and the microbiome. Here is the COVID microbiome versus healthy controls. We see 2 of our familiar taxa, Enterococcus, which contains 2 rather nefarious species, and Streptococcus. We see F. prausnitzii in almost all green. Watch these videos to learn much more. Here we have colorectal cancer, but just the bad guys because there are so many. I could not fit the good guys too on one slide. But take my word, F. prausnitzii has amazing data points here as well. Now the microbial fingerprint for colorectal cancer is a unique one, as it contains a number of troublesome species from the oral microbiome. But still, we see 4 of our consistent bad actors: Escherichia, where E. coli comes from, Enterococcus, Streptococcus, and Fusobacterium, which is a part of the oral microbiome. Watch these videos if you're interested in colorectal cancer. Now we look at Crohn's disease. Again, incredible consistency. F. prausnitzii has a tremendous number of data points and they are all green. In other words, in human original research papers comparing the fecal microbiomes of Crohn's subjects versus healthy controls, F. prausnitzii is always significantly higher in the healthy controls. This is no coincidence. We see 7 of our consistent bad guys play a role in the Crohn's average microbial fingerprint, each with all orange or mostly orange data points, one of them being Lactobacillus. Watch these videos to learn much more about Crohn's disease and the microbiome, and this video to learn why F. prausnitzii is the superhero of the gut microbiome. And here we have cardiovascular disease. Again, the same themes apply. You can watch this video for more. And here we have dementia. We have only 2 of our consistent bad guys here. One is E. coli, the poster child for opportunistic pathogens, and the other is, you guessed it, Lactobacillus. And once again, F. prausnitzii has stellar data points. Watch these videos to learn more. And here is the average microbial fingerprint for IBS, irritable bowel syndrome. Again, the same pattern. This is no coincidence. Again, here is the video for much more detailed information. Here we don't have my meta-analysis, but one done by other researchers who happen to use a similar color scheme. This is from my video on chronic kidney disease and the microbiome. These authors included 15 studies, and here we see comparisons in diabetic kidney disease versus healthy controls. Again, we see F. prausnitzii with great data, and Lactobacillus, E. coli, and Enterococcus with ugly data points. This is from my video on liver health. Once again, F. prausnitzii has all green data points, and we see 4 of our usual suspects. So as you can see in each of these slides, when there is a taxon with an orange column, it is always or almost always one of the 10 common opportunistic pathogens I highlighted at the outset, many of which are increased by antibiotics. Perhaps you can see the connection between antibiotic use and disease. When we combine the data points for both obesity and type 2 diabetes, we get this chart here. Again, the same pattern. And here, Lactobacillus has more bad data points than any other bad actor here, to include E. coli. So if you're taking probiotics or fermented foods and you're obese and or diabetic, perhaps you should rethink your game plan and focus on feeding the butyrate producers. Watch this video for much more. And here we have Parkinson's disease. Once again, incredible consistency in the data. The same usual suspects like Enterococcus, E. coli, Lactobacillus, and Streptococcus, which are increased by antibiotic use and consistently elevated here in PD, as well as in every slide we've seen thus far. It's not as if there is one bad bug for disease X and another for disease Y. These bacteria are drivers of inflammation, potentially throughout the whole body. As I often say, your health, or lack thereof, comes down to chronic inflammation. See these videos if you're interested in learning much more about Parkinson's. And for our last chart, we have my meta-analysis for ulcerative colitis. And again, no shocker here. We see the same bad actors as before, significantly higher in abundance in the ulcerative colitis fecal microbiome as compared to healthy controls. And we see F. prausnitzii was found in almost every study to be significantly higher in the healthy controls as compared to ulcerative colitis. And Lactobacillus, with total consistency, follows the same pattern as the known opportunistic pathogens. And we've already established that Lactobacillus is increased with antibiotics, while F. prausnitzii is decreased with antibiotics. So now maybe you're beginning to understand why I do not recommend Lactobacillus in those who are dysbiotic, and instead I aim to feed F. prausnitzii and its other health-promoting, butyrate-producing cousins, shown here and in all slides with green columns. Again, no coincidence. Watch this video for much more on ulcerative colitis. Now back to that point I mentioned earlier when talking about UTIs. You're not going to clear all pathogens with antibiotics. In fact, what you'll wind up doing is clearing out the good guys so the bad can take over. This is the case for a C. diff infection, and as well, antibiotic use is also a significant risk factor for a UTI. I will read the highlighted quote from this paper. Quote, that approximately 50% of recurrent UTIs are caused by the same strain that caused the initial infection argues for a host-associated reservoir that is not adequately cleared by current treatments. And what is that reservoir? The gut. Studies show that the majority of UTI-causing E. coli are resident in the gut at the time of the UTI, and UTIs are predominantly caused by E. coli, which is responsible for over 80% of the community-acquired infections, while healthcare-related UTIs, think catheter in the hospital, are associated with Staphylococcus, Klebsiella, Enterobacter, and Enterococcus. Do these names sound familiar? And just to drive home this point, these authors state, quote, however, many strains apparently cleared by antibiotics were observed again at later time points. In fact, none of the UTI-causing strains observed in the gut was permanently cleared following antibiotic exposure. And don't just think UTIs here. For whichever bad bacterium we're talking about trying to kill off may result in temporary relief, but in the long run is likely to worsen the situation. So stop spinning your wheels with outdated philosophies. As I've said a couple times now, after one round of antibiotics, the microbiome generally recovers. The real challenge is when someone has many rounds, especially in quick succession. This is when the real problems can begin, and especially if they have a bad diet or take PPIs, proton pump inhibitors. These researchers took only 3 subjects labeled D, E, and F and administered 2 courses of ciprofloxacin, then analyzed the fecal microbiomes. These 2 courses were separated by 6 months, which is still a bit of time. I'm sure some of you had one course after another before, in less than 6 months. As usual, there was a recovery, but it was not complete. Each gray vertical bar represents a course of Cipro. You can see, especially for subject F, that when we look at these 3 health-promoting taxa, Allostipes, Subdoli granulum, and Roseburia, there was a loss of presence in the microbiome, as highlighted by the red circles, showing a disappearance in detectability. Now, if you're like many people and you think probiotics will help you fend off the microbiome-altering effects of antibiotics, think again. First, as we saw earlier, Lactobacillus is consistently, significantly increased with antibiotic use. Second, as we saw ad nauseum, Lactobacillus is almost always significantly higher in the microbiomes of those with the condition versus healthy controls. And if that's not enough for you, we have this very comprehensive and invasive study. These researchers administered a substantial antibiotic regimen and then measured how the microbiomes recovered over 180 days in 3 arms. Natural recovery, what they call spontaneous, by fecal microbiome transfer, or with probiotic supplementation. FMT, fecal microbiota transfer, was the clear winner. Natural recovery was in second place, although 3 key health-promoting taxa never fully recovered. And the use of probiotics in post-antibiotic recovery had the undesirable effects of significantly delaying microbiome recovery until the end of the study, and causing a bloom in Enterococcus, which is a bad genus we've already highlighted. Now, I want to conclude with a few slides talking about something important that almost no one else is discussing: the relationship between the microbiome and bile acids. I talk about this in other videos, C. diff, liver health, and TUDCA, and we'll touch on it here. Why? Because bile acid dysmetabolism is a key factor in those who are dysbiotic. And the epitome of dysbiosis is a C. diff infection. But that's a misnomer. C. diff is not a problem for the healthy, but is a problem when the checks and balances are broken. With antibiotic use, as we now established, we kill off the good guys and ultimately the bad guys thrive. One of the things that these good guys do is metabolize bile acids. The first step is simple hydrolysis. About a quarter of your species can do this. The second step is dehydroxylation to convert primary bile acids to secondary. About 0.0001% of your microbiome possesses the gene to make this complex enzyme. An imbalance between primary and secondary creates an environment to enable germination and growth of C. diff. And this balance is determined by your microbiome, which is in turn determined by a few factors, in this case, antibiotics being of paramount importance. So our simplistic takeaway from the previous slide is primary bile acids bad, secondary bile acids good. It's largely the good guys who convert the primaries to secondaries. And when there are too many primaries, Toro coli to be specific, then C. diff may do terrible things. In this study, the use of vancomycin skyrocketed primary bile acids and plummeted secondaries. How? By killing off or sidelining the good guys who make this conversion. Please read the highlighted text for more reinforcement of everything I've been saying. To continue with bile acids in these finished children, macrolide use was associated with a 10-fold increase in the troublesome genus Agrathella. And as you can see in figure D, as time passed, the genes which direct the production of bile salt hydrolase took many months to recuperate. Again, from our previous slide, BSH, bile salt hydrolase, was the first step prior to converting primary to secondary bile acids. So even though some 25% of your microbiome possesses this gene, this too takes a hit from antibiotics use. The authors go on to state that it took 2 years for some aspects of the microbiome to recover after one single round on this antibiotic. Yes, the microbiome impacts bile acid metabolism, but bile acids impact the microbiome as well. So when you have the combination of bile acid dysmetabolism and dysbiosis, it's difficult to correct your gut. Which is why I so often hear from people, I eat healthy, but I just can't get any better. Yeah, I know, because you've done damage that's hard to reverse, and you need the help of someone who knows how to reverse it. And when we talk candida, which many people with dysbiosis have in spades, we see this paper in A and B that the secondary good bile acids, LCA and DCA, inhibited Candida albicans growth in vitro. To continue with the same paper, additionally here in a different A and B, these secondary bile acids also significantly inhibited the germ tube, hyphae, and biofilm formation in C. albicans. In other words, they made C. albicans less virulent. An altering of bile acids is critically important for the microbiome. This is how C. diff is able to be highly pathogenic and kill some people, while for the rest of us, we have no symptoms. It's the cycle of antibiotics, the killing off of butyrate producers, dysbiosis, the resultant inflammation, gut permeability, and bile acid dysmetabolism, which is at the root cause of not only C. diff, but everything I talk about. It's all connected. You can read the author's quote here, which says much of the same thing. The purpose of this presentation is not to contradict the orders of your practitioner, but to inform you. Anyone in the healthcare community with half a brain knows that antibiotics are overprescribed. But the definition of overprescribed is different for different people, and herein lies the problem. And although the overuse of antibiotics is a huge problem, the same types of microbial and inflammatory outcomes occur with PPI use, alcoholism, poor diets, and more. Just understand that the good and bad actors are generally the same from country to country and condition to condition. The principles are exactly the same. Fewer health promoters, bad guys take over, drive inflammation, and become more virulent in the pro-inflammatory environment. They cause gut permeability, and too many whole or parts of bad guys leak out systemically, along with food proteins. The immune system signals alert and attack on a chronic basis. And this can result in a slew of problems, autoimmune, in the brain, in the liver, etc. And this immune dysregulation plays a role in your food sensitivities and more. So think back. If you suffer from a condition, what happened in the weeks and months before the symptoms started? Were there one or more rounds of antibiotics on top of a long history of their use? If so, the antibiotic-induced dysbiosis in your gut could very well be the root cause. Let's fix that. And you should also note that I just created an account with the distributor Fullscript for US customers, which allows for easier and less confusing product fulfillment and a 10 to 15% savings on the products I recommend in my protocols, as well as any other health products you may use. If you liked the video, don't forget to subscribe. Also, somewhere around here, you can go to my website where you can schedule a consultation with me. You can also view the protocols, and here you can watch the next video.